Good morning, everybody. Lovely for you all to be here and to join in this first training given by Paul, who will introduce themselves. So my name is Thaisa van der Woude. I work for ISRIC and in the AUSO project, mostly closely working with Richard and Christian in Work Package 1. All these trainings are part of one of our tasks, which is online trainings to be provided on topics that are relevant for the AUSO project. So this one will be on FAIR, but thank you all for joining. And if there's any questions, feel free to put them in the chat. Myself and Louise will give the floor, and Paul will be there to answer any questions.
But let's continue for now. So we have the AUSO African Soil Observatory project, which aims to bring soil data from the various countries together and give a good overview of the soil, or at least improve the view on African soil health in general. We have Chipo Cosford here from Kabi, who will present nice work they've done on FAIR, quite recent. We have me doing a bit more the technical and more general aspects. So what is this all about? The value of soil data is often limited, mostly due to inconsistent documentation or poor accessibility. And then on top of that, there's a lack of interoperability because many of the institutes have their own procedures to either collect the data or work with the data. So these are typically the aspects that are considered by the FAIR principles to be improved. And they give a quite clear framework how to enhance those aspects. And in this workshop, we'll focus a bit on the general principles and then specifically to those in soil data. So these are the aspects from the proposal, the bit of the aims of the user project. So there's a big assumption and evidence that there is soil degradation happening in Africa. And there is a linkage to availability of reliable soil data. So the project aims to establish an observatory, like a central kind of hub that on one hand aims to empower the national institutes to capture that data, and on the other hand, bring that data together into a soil health dashboard to support the management of African soils. And here I explicitly mentioned 12 countries, and I hope we have most of those countries here in this meeting. Because these trainings help to equip these 12 countries with tools to actually improve these aspects in their organization. So the training objectives are recognize common challenges in soil data management, understand the FAIR principles, identify suitable repositories for publishing soil data, understand the role of controlled vocabularies. So you notice that's quite ambitious for a single training of 4 hours, but at least we'll hit the top level of these topics, so which are more kind of less a starting point for follow-up discussion in the coming 3 to 4 years. The audience: researchers and students, data stewards and support staff, environmental scientists that actually use the soil data, and anyone interested in open science and data management. So the FAIR principles were conceived in a workshop in 2014, and they address a bigger feel in that community that data sharing needs to improve. And they explicitly mentioned the aspect of machine actionability. So we're not specifically targeting humans here, Humans are probably well covered in reports and readme.txt where data sets are described. But this they explicitly mention machines. So also machines should be able to process the data in such a way that it becomes actionable. And here you already find in their leading statement as open as possible. So this clearly distincts the FAIR from open access. They endorse open, but if open is not an option, then as closed as necessary. So the FAIR is for abbreviations. We have findable, accessible, interoperable, and reusable. And I will go through each of these terms one by one to capture the aspects of them. If we look at the findable aspect of FAIR, then an important aspect is that the data and the metadata should be easy to find for both humans and computers. So here you already hear this aspect of machine actionability. It means if you have a very nice website with very nice colors, it's very easy for humans to find something. However, machines have a hard time. So you also need to provide a more machine readable format for your metadata that machines can parse. And an important aspect here is that each resource should have a unique and persistent identifier. They explicitly added this aspect to findability. However, as a human, you may think, oh, this is more on the accessibility side, but it is not. Making the resource available for the findable today, is it's also important that it's still findable in 10 years or 20 or 50 years time. That's why they added this persistent identification as part of the findability. And then the most expected topic here is that you need to provide rich metadata. So as much documentation as possible about the resource that you are describing and the context in what it was produced. Then let's go to the accessible topic. And this is more if the data set is available somewhere that you can access it and everybody can access it in a similar way now, but also in 5 years' time and in 10 years' time. And this is where aspects such as communication protocol and format become important, because a format may be popular today, but maybe not anymore in 20 years' time. And look at, for example, look at the XML. XML was very popular in the 90s and the beginning of the 2000s. But these days, people have a bit of a challenge to process these XML aspects from that age. The protocol should be open, free, and universally implementable. If Yeah, so here, please do not use a proprietary format. And a format of a software that is popular today but may not exist in 20 years' time, or some people cannot afford to buy the software and would not be able to access the data. Then let's go into the interoperable part. And this is a bit technical, but here in knowledge representation, consider that the user standard, that the vocabulary that describes your data in a standardized way, but also the data itself should be in a standardized format. And use vocabularies that follow the FAIR principles, because you can have a vocabulary, and actually the WRB is a very good example. It's a PDF report, the WRB. It's really difficult for machines to parse the WRB PDF document. And in that sense, we can say that WRB not nicely aligns with the FAIR principles. Um, if you use a vocabulary, make sure that it's also machine parsable. So machines can uniquely identify a term within the vocabulary. AgriVoc in that sense is better option. And include qualified references to other data. You know, the web lives due to all the linkages that are made between the different websites and images and videos. And the same applies to data. If your data links to other data, the whole system becomes much more reusable. Because if we, for example, we say we measured calcium, the definition of calcium can be found there and there. And another data set also says we measured calcium and the definition is somewhere else there. Then you're quite sure that those two data sets can be compared. Then finally, let's go into the reusable topic. Reusable is mostly a metadata aspect, which context and needs to be added to the metadata so people can easily reuse your data. One of the aspects here is that you need to indicate a clear usage license of the data. And provide a nice trail of provenance. So how was the data produced, so people know if it can be reused in another context. And also here, look at community standards related to usability.
So, morning again, everybody. My name is Chipo Cosford. I'm based in the UK. I work at an organization called Cab International. And we are part of the consortium that's working on AUSO. We are leading a work package 2, which is looking at which is the stock taking work package, where we're looking at assessing the enabling environment for AUSO, right? So what is the context in terms of the data ecosystem, data policies, national policies in the 12 countries and on the continent as a whole that will support AUSO and allow it to be sustainable. So the session that, I'm not going to talk very long, but my short presentation really is going to talk about the how some of the resources, the approaches and tools that we've developed at CABI to support or complement the technical approaches that you're going to hear about in this workshop. So ISRIC is going to talk a lot about tools and resources that can help you technically achieve the FAIR. And what I'll talk about is what are the other issues that are sort of surrounding the technical? What are the sort of things we need to be thinking about and addressing that might prevent us from even achieving success using the technical tools, if that makes sense. So as I go along, I'll talk about what we see as some of the issues that we've seen on the ground when we are trying to implement data-rich projects, and what are some of the resources that we've created to help break down barriers and achieve success. So, yeah, so really, I mean, from our work, and I think even for you as well, you've seen that in a lot of agricultural data initiatives, we're continuing to see a common set of challenges, right? We've got these, it might be a research project, or it might be a project where you want to develop an AI chatbot, for example. We have these challenges around fragmentation of data, right? So they're valuable data sets we would like to have access to, but one, we don't know whether they are whether they exist or not, whether that data has been collected ever before. And if you know it's out there, you actually don't know how to access it. It's not clear, it's not evident how you can get your hands on the data. There's inconsistency. So this is what some of what Paul was talking about, right? Documentation, the metadata is missing or it's incomplete. So it's very challenging to understand what this data that you have found is and how to integrate it or combine it with other data sets. And then there are other really legitimate concerns around ownership, around permissions, around the risk of misuse, right? So, what can I do with this data? What can't be done with it? Or our organization doesn't allow access to this type of data and so forth. So, these are some of the barriers and challenges that we're seeing within the agricultural data ecosystem. And this important one, which is around the sustainability, what happens when the project ends? How do we ensure that this data that we collected and spent a lot of money on will continue to be available even to ourselves, even to the organization within which we work for the long term? It's not like Paul gave the example, someone left the organization with a laptop, the data is gone with them. How do we ensure that these sort of situations are not happening? Because with these type of problems, what we are seeing is, as a result, is that there's a lot of duplication of effort. We're collecting the same data over and over, working in silos. There's very, very low levels of collaboration when it comes to data sharing, data exchange. And ultimately, it's going to lead to, in the long term, lower impact, lower return on investment by the donors that are funding these projects. So that's the problem landscape, right? And now what FAIR is coming in to do is to help us to give us a framework to try and put things in place that will allow for better access to data, better sharing of data consistently and over a long term. So this training will talk a lot about the technical foundations that need to be put in place in a project, the technical considerations, technical foundations. But what in this presentation, what I also want us to keep in the back of our minds, and as we continue working on the various projects that we belong to and AUSO itself, is what are the organizational foundations that need to be there as well, right? So on the right-hand side, I have things like governance and policy, roles and responsibilities, data sharing, agreements, alignment among stakeholders, and that institutional buy-in that will guarantee you sustainability in your project. So these organizational foundations will prompt you to start to think about things like, who is responsible for data stewardship in this project, right? Do we have a person that has been allocated and time and resources for this? What about when we're talking about data sharing? What data can and can't be shared, and who decides, right? Who even determines that? Who makes that decision? Do we have a name, an allocated role for that? And if we're working in consortiums, as we are increasingly doing more and more, it's very rare for you to get funding on your own as a single organization in this landscape that we're in. We are working across different countries, different geographies with their own each national policies and so forth. How do we get different institutions in different countries to agree on shared expectations, right? While the donor has their expectations, each and every country has its own sovereign way of handling data, and how do we come to an alignment on that? So these things can make or break a project, no matter how much resource you put into having the right tools and resources, which is so important and critical. And I'm so happy that we're having this workshop. It's important that we ensure that some of these softer issues, which will continue to follow you throughout the life cycle of a project, if they are not addressed and are not discussed and are not agreed. So yeah, so really it's just this my session is to highlight the importance of these and to highlight some tools and resources and approaches to how do you actually have these conversations and come up with agreements and document it so that everyone in the consortium is clear and aware how we as a project, as a program, or as an organization institution will handle data. Good. So I'll talk in the next few slides just about some of the resources that we've created at CABI, which are all open access and are there to be used. We're open to getting feedback on these resources. And yeah, we really would love for people to trial them. So what I have on the screen here is how we see these issues of data, right? And I think increasingly more and more, especially donors, they're really starting to expect this, that planning for data management planning for data governance should be done early within a project lifecycle, right? It becomes very, very difficult and very expensive for you to try and retrofit good data practice once your project is operational, or sometimes even at the end, right? You've seen it. It's only at the end sometimes that people start thinking, oh, okay, so where are we going to put our data? Or your donor is asking to have access to the data, and then you now need to start thinking about, is it clean? Does it have all the right metadata? And that takes time and it's expensive. So we're saying the earlier you start planning and thinking about this, the higher the level of FAIR maturity you're going to have. So your data is going to reach, FAIR is a spectrum, right? So it could be right at the real good quality data, ranging from really poor quality data to really high quality data. And it will cost you less because you've budgeted for this, right? You have a plan in place and how much it might cost you and so forth. And so in AUSO, we've taken this approach where the whole first year of the project almost is really focused on just understanding the enabling environment, understanding our stakeholders, what their needs are, and helping to inform the design of AUSO before any work has even begun on actually designing the system. This slide here now is the FAIR process framework. So 2 years ago, we developed a framework. Essentially, it's 6 steps. 6 steps to walk you through thinking about, prompting you to start to consider what could potentially be bottlenecks to your data-rich project, right? Any type of data-rich project where you're either collecting data or you're analyzing data, processing data, or where you're storing data. So all of those elements of a data lifecycle are probably happening within your project. So what this framework does is to help you move you from a phase of discovery, where number 1 and number 2, step number 1, number 2 are really looking to understand. So within this context, within this institution that we're working, or amongst these partners, do we have any assumptions we're making about data, and helping you articulate them and interrogate them, challenge them. Are there things we need to understand about each of the different geographies where we're working that might end up becoming a bottleneck and barrier for us? And then it helps you to start, as you move into the middle section, it's the planning around the data sets that we want to collect. Are we assuming some of it will be available? You've seen projects where we know one ministry has a certain data set that will be very useful for our project. The Met department has this data set, and we have a good vision. We've got an idea how this project is going to go, but none of it has ever really been tested. We don't know whether it will be accessible or not in the end. So it helps you document those. It helps you start to put a plan together. And then as you move towards the far end of the framework, you're now looking at actually implementing. So now you have a data management plan, for example. You're now thinking about, so which standards are we actually going to select and documenting them and so forth. So yeah, so on the high level, this is what the FAIR process framework gives you, and it just gives you resources and tools to help put a solid either proposal or plan in place. One of the things that I was going to say about it is, ideally you would be doing this at the beginning of a project, right? So you're thinking about these things as you're writing maybe your proposal, as you're putting together your budgets and things like that. But often we know there's not a lot of time. Proposals are put together very quickly and decisions are made very quickly. So we've tried to make it flexible to allow you to enter at any point within of your project at the very early beginning, or if you're already partway through, you can still go back and use these resources. So yes, so this is just to give you a snapshot of the FAIR process framework. These are screenshots from it. That is the URL. Would love for you to visit it. One thing we recognized very early on is how time poor, we all are. So we've tried to create resources that are brief, that provide different ways of consuming the information. So a lot of visuals, videos, short explainers. We give templates. and case studies also for you to see how others have done some of this work. So this is the FAIR process framework. Here you can see these are just the various types of resources that are all on there, ranging from, like I said, where you've got exemplars, case studies, all the way to lists of existing repositories. For example, you're not sure what repository to put your data on. We've tried to collate lists and lists of thematic repositories that exist for agriculture. Licensing, that's often a topic that a lot of people struggle with, right? How should I license this data? What do each different type of license mean, and what could be relevant for our project? Yes, and so I picked a few examples to show you, because these are common documents that many projects will need and would love for you in your context. We're using them in AUSO. If you have any projects that you're working on, they've been tailored for agriculture type projects. So it's a good starting point, and would love for you to take them and adapt them. This here, what I have on the screen is a data governance policy template, right? So you might find, like I was saying, you're working with multiple institutions in a consortium, right? We need to agree who is responsible for what. We need to agree what data will be shared or not. So the high level principles of this project or this consortium that we all say we're going to stick to, what standards of privacy are we going to stick to, how do we ensure compliance, and so forth, and so that everybody is just clear that these are the high level principles that govern how data will be used and within this project, how it will be managed. So at that high level. And the template gives you examples, gives you, if you're not sure what goes into a section, we've tried to tailor them so that they include examples and links to other reference material where relevant. So that's one that I have there for you. Another one I have for you is a data management plan template. So these also are increasingly being required. So the EU, for example, requires that every project, the projects that they fund, must submit one within the first 6 months of the project. So that just shows you that this thinking needs to be done early on in the investment. You don't wait till later, because by then, it's hard to start undoing things or correcting things. So we have a template there that's got 5 core questions that, even if you stop at those first 5 questions, it's already putting you in a position of being able to handle your data appropriately. Later, as the project progresses, this is a living document. You come back to it. You start to, now you know more, right? You know exactly what data is needed in this project. You might not know exactly at the start, but the more you see what the gaps are, okay, now we've decided this is what we're going to collect. We update the data management plan. Now we know more about which standards are actually relevant for this work. We go back, we update the metadata section, for example. So this is another tool that you can make use of. And the last one that I was going to show you is data sharing agreements. So again, very useful in collaborative cross-institutional projects where different partners will have different expectations or different concerns around ownership, right? This issue of ownership, we saw it's influencing a lot of the decisions around what repository we're going to put our data on, right? So ownership is something that should be addressed and should be written down within and assured within an agreement. Attribution, that is an important one. You're doing all this research work. How are we going to ensure you get the attribution, you get the acknowledgement for the work that's been put into collecting this data? The publication rights, how are you going to are we going to allow this data to be published on an open repository or not? What about commercially sensitive data, right? You might want to later on commercialize some of it or create more outputs from that data that you could use to sell and so forth. So it gives us this template will give you a lot of terms and conditions. We've color coded, different options that you might want to look at and choose from, almost like a menu, a guide. And a lot of legal documents are difficult to understand. So we've tried to put in the explanations of what some of these terms means to try and simplify it and so forth. So this is a really good template that we're also using in AUSO. And, you know, like I said, we continue to learn and evolve, and any resources that you know are used out there, we would love to hear back from you. What you thought of them, or how you have used them, especially because use cases will be different. And what a data management plan will look like in a straightforward research project will be different. So how can you customize it? Because they are flexible tools. Customize it for a project that's working on an AI model, an AI LLM model, or something like that, right? So yes, so this is what I had that I wanted to just share with you very briefly. To just wrap up, these are important topics. Let's not forget them. They take time. I know people have concerns about, putting such documents together, that it takes time to bring stakeholders together and agree, but it's worth it in the end if we want sustainable access to data when our projects are complete. So here, there's the link again if you need it. And thank you, ISRIC, for giving us this opportunity, and we hope to continue to work together in the future. Thanks a lot.
Well, welcome back, everybody. So this morning we've looked at the general topic of FAIR, what is FAIR, and this afternoon we'll dive a bit more into how is this specific to soil data, and yeah, some practical exercises on where do I find a repository, and how can I access that. So in order to understand the topic of FAIR metadata for the soil domain, it's important to identify typical products that we use in the soil domain, because you will notice that for each of them we have slightly different recommendations. So let's dive in first. So we often tend to look at soil and land observation data first when we talk about data, because they are the source of all the soil health indicators, predictions, etc. that we base on those data. So soil and land observation data is an important aspect of our work. And this also includes lab experiments, controlled experiments in either how do you say, testing farms or university laboratories, where the behavior of soil under controlled climatic conditions is analyzed. Because this is where kind of the knowledge on soil is based on. On one hand, we have experiments under controlled conditions. On the other hand, we have the distribution of soils through the country to understand the whole soil behavior. But both can be captured as observation data. So here they are. So we have soil and land inventory at given geolocations and time, and we have data from a lab or field experiments. Then we have another segment of products, which are more derived maps and products based on those soil data. We have aggregated harmonized data sets, which are derived product from the original sources. We have predicted distribution of soil properties. Of course, we measure at point A and point B. We never know what's in between unless we predict it with some statistical or machine learning algorithm. And we have optimizations of soil health, erosion, yield, etc., prediction data. And then we have other data products. In this case, one to mention specifically are the covariates. And covariates is typically um, data source that is used in this machine learning mechanism to make optimal predictions. For example, digital elevation model. Let's look at how high is a certain landscape. Often has a direct connection to the soil type, soil depth, soil properties at a certain location. So if you use those covariate data, you can better predict the soil condition at a given location. And for each of these products, we kind of have special aspects we have to look into. So geology, satellite data, land use, climate, those are typically the covariate data that is not directly produced by our departments, but usually it's used. So we're more a consumer of those data products. So what are then the common challenges in the data management? A big item in a lot of the research ongoing is, are we even aware that the data exists? So very low findability of data on a certain topic in a certain region or time frame. And sometimes this is hindered by the fact that the organization that owns that data doesn't properly advertise that they have the data. But sometimes it's more rudimentary in the sense that they do advertise, but not on the channels that I'm looking for it. So then there's kind of a discontinuity between the different communities where the consumers are and where the producers are. And then another big challenge is the information loss at project finalization. We see, or somebody moves to another job and takes a lot of knowledge with him. So this is also a big challenge. And then when we go a bit more into the interoperability of things, if vocabularies are not well organized, then the data may be available, but not really usable because they're so disconnected. And then specifically for soil data, we typically see, for example, gaps in observed soil properties over time or over space. So in some areas, there's more sampling done than in other areas, but also in time. If you want to make a soil health analysis over time, did the soil health decrease or increase? You need like a continuous sampling over at the same location. But there can be a gap in time also. But here also is mentioned that the a gap in the metadata. So if for a certain data set is not known anymore which procedure was used to assess the variable, you cannot really use the variable because you have no clue how it was measured. And this is more when you're using a soil map that you find somewhere on the web. You're not really sure, and if you're not sure how it was produced, you're not sure it really fits the use case that you want to use it for. And this is also one that we now and then see is that producing soil maps, so predictions of soil properties, is not very commonly done in different topics and regions, which makes the maps also different to compare between regions or times or topics. So how can you create a map in a standardized way is also a topic of interest to a USO project. Then let's go into the repositories and aggregators topic, which we already touched on, but this morning, but now a bit more in the practical sense. So repositories are the kind of the primary place where you publish or archive data, and they store the data under unique identification. And unique identification actually very important, because if you write a scientific article and you want to make a reference to the data set, you typically want to reference the data set either with a citation or with a persistent identifier such as DOI or handle. So if the article gets published a year later or read by somebody 5 or 10 years later, the link in that article still resolves to the original data set. In those repositories, the data, this depends a bit on which repository, but most repositories allow you to publish the data set either under an embargo, saying, hey, this data will be released in 10 months' time when all publications are done, or fully behind the password that you need to confirm if any person can access that data. And then consider, so we had that questions before, like how many repositories are out there, and then I just checked on. I'll put a link on the chat later, but in OpenAIRE currently harvests from 160,000 repositories, and a lot of them are academic articles. So academic article publishers which have their own repository and are harvested by OpenAIRE. But it's good to keep in mind that there's a huge amount of repositories, and you're not going to each one individually to search for an article or data set. So you either use Google or you go to one of the aggregators, and the aggregators. And in a sense, Google is also an aggregator. However, that one indexes the full internet. The aggregators only harvest the content from the academic repositories. So yeah, so a repository is for storing, not necessarily for searching. And then the aggregators such as OpenAIRE, OpenAlex, Google Scholar, Web of Science, they index the content from the various repositories and provide a search interface to find those data.
Well, I just wanted to know if I know that Jipo gave us a step process for making the data fair, and how does it fit with this one for practical purposes? Let's say, for example, I have my data and I want to make it fair with the practical that you're giving now.
Yeah. Yeah, so at the moment we're looking at the findability of the aspect of the FAIR. In the next topic, we'll go to more into the interoperability of aspect of FAIR. So the findability aspect is relatively simple. You select a sensible, legible repository that meets your requirements, and you publish it here. I have an example here, which is from Zenodo. Where of it here? Zenodo is a big repository in Europe, and it's one of the only ones where you can publish data without any financial or restrictions, and it has a sensible continuity strategy. So I logged in as myself. You need to, when you register here, you need to register with an email from an academic institute, but they are really open. I've not heard of anyone being rejected here, but typically you can easily create an account here and start contributing. And here from this option, I can do a new upload and drag up some files and then start creating the metadata. So this is kind of an obvious form with typical fields. First one, it says, do you want a DOI for your upload, or you already have one? And it happens. Sometimes you mint the DOI as part of another process, for example, an organizational process. Then you can put the DOI here. But if you don't want, then Zenodo will provide one for you. So in this case, they created this DOI for my thing and say, okay, this is going to be a data set. And a title is Observations from the AUSO FAIR training. Publication date, and here I add the authors. And this is an interesting section because it allows me to put the person name and the given name here, which would be my name, for example. But they also give the option to give an ORCID. An ORCID is the stronger choice here. Maybe you heard about ORCID. ORCID is a system that aims to register all scientists in the world. So if you ever publish an academic paper or whatsoever, you are likely here already. So for example, I'm here. This is my persistent identifier of ORCID. If I put that here in Zenodo, and then it will automatically know it is me. Let's do that again. This one. Oh, going out. Sorry. Select this one. Yeah, so here it already knows my affiliation, that I'm part of ISRIC World Soil Information. So this is a much stronger choice than then giving the personal name, Paul van Genuchten, ISRIC, and everything. Also on the back end, Zenodo will link the ORCID and yeah, so it's a very strong case for the use of vocabularies. This is really me. So now you also see here the green button saying that this is originating from ORCID. Then we go to the abstract, and the license is pre-populated with CC by 4, but of course you can change that to any other license. Some copyright information. And then we slowly arrive in the optional information. You will notice that there's a lot of optional aspects that you can add to increase the fairness of your record. But with if you just populate the required fields, it's enough to publish. And so at some point we can say preview the thing, and then I actually did not upload something. I need to upload a work for it to be able to be published. I can then ask a review to a colleague. Please, colleague, review this. And then at some point when we align, we get here the publish button available. And from then on is available. Later, when if I go to my dashboard, I see all these things that I published before. So for example, this is a snapshot of the land soil crop project database that I published last year.
So, yeah, hello, Paul. This is Benjamin. Maybe Francis, I mean, the question on the D space, what you about FAIRA.
Oh yeah.
Yeah, maybe Francis can just quickly um just show how it works on our side.
So the AA space is basically built on eSpace. And then we have been working in collaboration with ILRI, who are the custodian of the CG space, also built on DSpace. So just we were hosting our library in a WordPress platform, but at times it becomes difficult for search and all those things. So we thought it was okay to move it to a repository. So looking at what the CG space has done, which was quite remarkable, we decided to mimic the CG space platform. So the CG space actually has all the CG centers having their publication in one repository, being managed by ILRI. So we thought it wise, as a CADEP XP for institutions, thought it wise to come together and also do something similar like that. So we have FAIRA, we have CORAF, we have ASERECA, and then CADESA coming together to have one common space. So that's why we call it our space, the African Agricultural Space. Actually, that's the AA stands for African Agricultural Space. So basically, that was the idea behind it. And the initial idea was basically for publications, actually. So you see this, that we don't have data sets in here yet. So we are only using it for publications. So that is the basic idea of the R space. So when you go to the homepage, you would see that we created we call it this space has called it community and sub-communities. So we created communities for all the centers. This is for CADESA, and then we have the FARA one. We have one for AFAS, and then we have the ASERECA and the CORAF. So we created a way that each institution can manage their own space. So FARA, we don't have to be in CADESA space to do anything for them. They can manage their own space and give access to whoever they want to give access to. So I'll just open the FARA one, and then, so we also registered a handle. So we have the persistent handle that we are using, which applies to all the other institutions. As soon as they create their items, they'll get the handle as well. So just to, go to how to add an item. So you can create a sub-community, you can have a collection, and under the collection, you can have an item. So to add an item, maybe I want to add, we have a new annual report. These are the few collections and communities we have created so far. So for instance, just as Zanado, you can have the altar. I won't fill all these things, but we just go through the fields. So if you have 2 or more authors, you can just add. You could just keep adding as many authors that you have, you can add. And then the title. So there are certain fields that are, mandatory. Some are optional. So we have other titles too, which you can put. So if you have more titles, you can just be adding up. And then the date of issue, that one too is compulsory. And then we have the publisher. Then there are certain options that we have created ourselves, like the donor. This is a custom field we added. The donor, the region, and the sub-region because of the way we are working. And then the country. It also comes with a DOI, and the journal. If you have to publish in journal, if you are publishing journal, which type of journal did you publish in? And then if the publication is also under a project. So some of these custom fields were added by us, were defined by us. So we can define as many custom fields as possible based on your needs. And then we also thought that we should add an outcome area. If the project is having an outcome area that you want to capture, and then we also added, we have what we call dissemination notes, which comes in series. So as I said, based on the need, we keep adding some fields, which we made them optional so that if your project does not conform to some of these things, you can still submit an item. And then there is an ISSN also. Then this type, we haven't added any yet. These are the ones that came with this phase, but we can add more. So I see we have data set here. We've not tried adding a data set, so there's a data set version here. So normally we add the book and the articles, and then you can also determine the language. This one, you can also add more. And then these fields, this is where you put the abstract. And then if there are any sponsors in the description. So basically, so when you go through this and you save, there's a workflow as Paul also showed on the other one. So I can add a colleague. I can click on the save, and then it goes to the next person. I can define a number of workflow or reviewers, 4, 5, depending on how I want it to be reviewed. So if I save now, it goes to the next person to be reviewed. The next person reviews and saves it, and it goes to the other person until the last person, and then it is now published finally. So basically, this is how it works.
Yeah, oh, there were actually some more lines here. In that exercise, if you found a data set, try to use the metadata to understand the data in that context and to find any related data or publications or vice versa. If you found the publication, can you find the data set? If you find the data set, can you find the publication, the report about this data set? Because that's important, because the report typically helps us to understand the data set and vice versa. And then a bit about the not finding case. So can you find some data which isn't, do you know if some data exists, but which you can't find through these channels? And then that could be an interesting point for conversation, like, hey, why can't this resource not be found? And then the last comment here about this citation. If you would write a report about a data set, how would you cite the data set? Would you just give a citation saying Janssen, Peter, 2026, a data set with this nice article? Or would you be able to add a DOI or handle where this data set is actually published? Where the second case is much richer than the first case. Then let's go into this process of identifying relevant repositories. Also considering this aspect that Martin raised just now. The first point is to go to the funder obligations. Funder plays an important role in establishing the fact that research deliverables are properly archived. It gives them, so sustainability is crucial to them. So they funded the research, so they want the results from that research be accessible to everybody as long as possible. So if the sustainability of the repository is an important success factor of the selection process. How do you do that? It's a difficult question because some repositories seem very sustainable, but then all of a sudden disappear. And I guess there are some good examples even in the Google or Microsoft space of initiatives that seemed very sustainable, but may not. And then the third point is, does the repository provide persistent identifiers? Let's dive a bit into what are persistent identifiers after this slide. And then the fourth aspect is the repository connected to the common aggregator? So it links a bit back to our previous question. Were you able to find a resource that you know exists, but it may not be available to one of those aggregators? And if that's the case, then it's important to connect to the maintainers of your repository, to ask them to connect to OpenAir, OpenAlex, and the likes, to say, hey guys, we're here, please harvest us. And the same actually applies to Google. If your repository is not identified by Google, your site administrator can connect to Google via the Google Cloud Console to indicate, hey Google, there's this nice repository here that we like you to add to your index. So this always requires action of the maintainer of the repository. But you, as a user, can trigger that conversation by contacting the maintainers of the repository to take action. One to mention here is also Crossref. Crossref is also an academic community initiative which mostly links articles to each other. So if one article cites another article and another article, another article, they aim to establish all those linkages between articles, datasets, and academic works. Also a very interesting initiative. And then to add a bit on top on the completeness of the metadata model. So on one hand, we have the DataCite metadata model, which is adopted by the common repositories and has the common elements such as title, abstract, keyword, publication year, publisher. But some repositories, especially topic repositories, for example, in the genome area, have very dedicated fields related to genomic research. And finally, the completeness of the metadata model. I am not aware of any soil related repositories that typically go into the topic of soil. But it could be one of the outcomes of AUSO that we have some very specific soil related fields be integrated in some of the commonly used repositories. And then some examples. So space we just looked at, the Calro e-repository, which has a lot of interesting aspects. We have Zenodo seen it. There's Pangaya.de, is a German initiative which has a lot of data sets in the like environment, Earth domain. Very relevant to us. There's the Open Science Foundation, which hosts all the links of the AFSIS and Pangea soil. So here we have a lot of soil data, but then this is still global. So let's look at Africa, Ghana. Yeah, so it's a nice one to browse through, but consider it is a repository, so all this content will also be available in the aggregators. And then we have Open Science Foundation. This is, for example, a data set from the Rwanda Soil Observatory that is managed by this group of researchers, and they use this Open Science Foundation. And I was not able to found this data set through the other aggregators. So, but I know that some of Open Science Foundation is actually harvested by the aggregators. So I'm not sure why this one specifically was not harvested. But in general, Open Science Foundation is a valid. They also provide DOIs for their data, and it's an interesting alternative to some of the other repositories. See, they have a DOI for each publication. Harvard Dataverse platform is often mentioned because the Harvard Dataverse platform itself is a big open data space. On the other hand, it's also an open source software project, so you can install the Dataverse software on your local server, and kind of there are a lot of organizations, such as, for example, Dataverse NL, which is kind of the Dutch repository. They use this software to host um, a repository. I think the same for Sirat, Salim. Yeah.
Yes,
So
indeed. We have the same solution, same software. So we have approximately the same type of metadata to fill in and the same policy approximately. So after the usage of these dataverse platforms are really used on the policy of the organization. For example, if you are working with an institution, with Harvard or with CIRAD on our site, so you have to have an account.
And then there's more community academic initiative is Data Dryad. It's an American foundation that is also quite commonly used if you analyze the contents of some of the aggregators. Figshare, also, this is an old one, also used a lot in scientific domain. They present nice visualizations on top of the data. And so the list is really huge. This is just a representation of some. The Gates Open Research is in that sense an interesting repository, because it's really here the funder more or less stood up, said, "Hey, all my research needs to be properly deposited. That's why I create this repository." So a lot of the Gates funded research has a requirement to publish their outcomes in this repository, which is also, from a funder perspective, really interesting choice they made. That's the next topic. So we go into the interoperability aspect of FAIR, and here we really touch on the soil topic, because vocabularies are typically, although there's very generic vocabularies, there's also in the soil domain we have some specific vocabularies. So vocabularies improve findability. So if I look, in catalogs typically have two ways of entry. When you look for a search term, and it will use an any text kind of hitting mechanism to find it. For example, if I look for forest, it will look in the title and the abstract for forest, and it will find a lot of hits. However, if the data set has a keyword forest, you typically use a different filtering mechanism in the sidebar. So saying keyword should be forest, which is a much more exact filter, because, for example, it can also hit on the French word forêt, or the German word Wald, because the keyword inherently has all these translations embedded. That's why the use of controlled vocabularies such as AgroVoc is very important when you annotate your data to improve the findability of that data. The same applies to the ORCIDs that we've seen, persistent identifiers. Or actually here is meant that the word forest for wild has a persistent identifier in a controlled vocabulary, which you can use. Same. Oh wait, now I'm lost. Yes. So the controlled vocabularies also have hierarchical relationships. Let's look at AgroVoc for a moment. If you look at this term forest, yes, here the term is actually forests. Here you notice that forest is part of a hierarchy. So there is a broader term, vegetation, and a narrower term called closed forests, communal forests, disturbed forests. And this hierarchy of terms allows catalogs to increase the search term. If it finds very little hits or too much hits on the term forest, it is able to provide you a list of more detailed aspects to make your search refiner, or bigger if it's too small. And AgroVoc is an interesting vocabulary related to agronomy terms. So most of the terms that we use in our daily work are probably represented here. And the other thing that can be used, where these controlled vocabularies can be used, is to cluster records based on the categories. And that which gives us nice overview of statistics. How much content do we have about forests in this catalog? How much about soil? How much of, which is a nice view to administrators to understand where that contributes, where the catalog contributes most. The other aspect is the interoperability of the data. And here we reference a bit the procedures, units of measures, and the soil properties itself. So we have a shared understanding within Africa which procedure was used, or when planning a new sampling campaign, which procedure to use. And then some examples here. So on one, we have already seen the DOI and handle system, where each work gets a persistent identifier. We've seen ORCID. ORCID is to identify authors in academic publications. We also have ROR, which is an organizational repository. So, for example, if I go to roar.org and I look for ISRIC, then you notice that this is the ROR identifier of ISRIC. And typically you can find most of the research institutes here. If not, then it would be nice to add your organization. So you can, whenever you create metadata, you can easily reference the organization by its identifier. And here are a list of more content vocabularies. In AgroVoc we've seen GEMET is an environmental thesaurus of the European Union. CAP was also mentioned in the Menti, and these are very agronomy related terms. And QUDT is actually the one that is used for unit of measure. And it describes things such as units, dimensions, contents, and So every seconds per meter, gram per liter, all these things have a unique identifier in this system. In the EU, in the SOLWISE project, where also me and Celine are working, we're setting up a soil vocabulary with all sorts of procedures and properties that are relevant for the soil domain. So this is how it looks on the front end currently. It's a work in progress, so we're still working on that. So here we have, for example, the soil chemical properties, typical. Where are we? And then as soon as you're in the exact property that you're observing, it gives a list of procedures that are commonly used for measuring calcium, magnesium in samples. And here is a convenient copy URI, which you then can put in your data to say, oh, we've used this procedure. In that case, you don't need to write out the whole procedure that you've used, but you can just put a URI reference for this procedure. And this is now hosted at the EU SoilVoc, which as part of this AUSO project, we can see if we maybe need an African alternative to this vocabulary. Then let's go a bit into the actual topic of we call it ontology or data model. How can observation data easily be shared? And here that in the soil community, we adopted the observation measurements and samples model from the Open Geospatial Consortium meeting community. And here you see that this OMS model is adopted by various very common standards in the soil domain, such as ISO 28258, the Inspire Soil, and the FAO glosses. So there's a wide adoption of the OMS model, and which makes, when adopted, makes the observation data quite interoperable in the domain. And we'll not get into much details about this aspect, but it is something that we want to explore with you in the coming years to see how we can facilitate that adoption. In OMS, each observation result is annotated with an observed property, being calcium or magnesium from a code list, the procedure under which it was being measured, and the feature of interest, being the landscape or being the actual soil sample taken from layer 2, depth 10 to 20 centimeters, as well as the time and the location of the observation and the unit of measure. So all these aspects are more or less packed into the data, which is a precondition later to harmonize the various data sets from the various sources. And because soil data is typically tabular, we've seen that a lot. It's either in CSV or Excel or some database format, where you typically have a tabular format. And here we suggest an approach where these annotations are brought at the column level. So for this sampling campaign, we measured this species Brachybodium retosum in gram per meter 3, and we use a procedure of dry sieve and weigh, and the thing itself is a SOSA observation. So this is an approach that we're now experimenting with in the Solwise project, and we think it's a very feasible approach to annotate existing data sets prior to their to enrich the harmonization aspect. Going back to the previous slide, a lot of this metadata is currently captured in reports or README files, which is not really machine actionable. And with this approach of annotating the columns is called CSV on the web. It's a standard that provides a way to annotate tabular data. And if we then, in this annotation process, use these controlled vocabularies, then we really have this rich interoperable experience. And well, typically you upload this CSVW data with the data set. So it's just a sidecar file with every data set that you upload to a repository to enrich it. So that's one of the approaches that is available to annotate your tabular data to make it more interoperable. So then I don't have very specific examples on reusability, but maybe we will develop some of those during the project. We can, for example, discuss licensing, harmonization of licenses. Very typically, in a lot of contexts, very specific licenses are used. But if you adopt very generic CC by attribution licenses, it's much easier to evaluate for the users if they can use the data for a certain scenario. Well, in general, what we learned this afternoon is that the FAIR principles provide a framework to enhance usability and impact of soil data. We've seen challenges in soil data findability and usability, and the fact that repositories and aggregators play an important role in making data findable and accessible.